Okay, functions, we are going to talk about special right triangles. So the first thing I want to do is I want to show you how you can make these two triangles no matter what. Given any circumstances, you don't have to memorize anything, but you can find these triangles. So the first thing I'd like you to do is draw an equilateral triangle with a side length of 2. And the reason why we want to do a side length of 2 is eventually I'm going to break this in half, and breaking 2 in half is an easy number to break in half. So that is why we're going to do a side length of 2. So if I do that, the interior angles must be then 60 degrees, right? So if those are 60 degrees, there we go. All right, so now I said I wanted to break this in half, because the only way that I could make this into a right triangle is if I split it down the middle right here. Honestly, I could split it anywhere I wanted to. It won't matter because it's an equilateral triangle, but for visual effects, I'm going to split it right down the middle, right there. And when I do that, I create two identical right triangles, right? This becomes a 60-degree angle. I cut this in half, so now this angle right here is 30, which would make this angle 30. This one is 60, and this again would be 90. So I've got two identical triangles. So I really only need to solve and find the 6 trig ratios for one of them. So I'm going to go ahead and look at that triangle. So I said that we made this a side length of 2. We made that 30 degrees. Then what must be the length of this if I cut it right in half? Well, it's going to be 1. And if I make that a 1, how do I find the missing side length? Well, that's where I'm going to use the Pythagorean theorem. So I'm going to do 1 squared plus b squared equals 2 squared. Now remember, whenever we're using the Pythagorean theorem, whatever the side length across or opposite of the right angle, that's what it needs to be equal to. So I end up that after solving for everything, I end up with the square root of 3. Okay, so now what I would like you to do is I would like you to find, and I'm going to do the first one, but I'm going to find the sine, let's see where my mouse is, here we go, the sine of 30 degrees. Okay, so before we were finding like the sine of A. Well, let's just pretend this is A. We'll do it the exact same way. So 30 degrees is right here. So then I want to do opposite over hypotenuse. So the opposite side is 1. The hypotenuse is 2. And I just found the sine of 30 degrees. I would like you to do the rest. Do the other 6. After you find the sine, the cosine, the tangent, the cosecant, the secant, the cotangent of 30 degrees, I'd like you to do the same thing for 60 degrees. So you should have 12 different answers when you are done. Okay, so I'm going to put my answers up. It looks like I did the sine of 60 degrees first, and these should be your answers. And then I did the sine of 30 degrees, and all of them for 30 degrees. So check your answers, make sure that you get them right. Something I'd like you to notice that the sine of 60 degrees is the same as the cosine of 30 degrees. The sine of 30 degrees was the same as the cosine of 60 degrees. Just something to notice. It might come up later. All right, let's do another special. So this special, we're going to start with a unit square. So a square that's a 1 by 1 by 1 by 1. The reason why we're doing a 1 by 1 by 1 by 1 is it's just an easy number to work with. And we have that 90 degrees in the corner, so we know that we're dealing with a square. And to put this into two identical triangles, we're going to draw a diagonal line right through it. So then I've got, this was 90 degrees, but now that's going to be half. So we have that triangle. And so if that's half of 90, then we end up with 45 degrees there. And then we end up with, and we end up with 45 degrees there. Now we need to solve for the hypotenuse because we created this hypotenuse right here. How do I know it's the hypotenuse? It's the opposite side of the 90 degrees. So the first thing I'm going to do is do 1 squared plus 1 squared equals c squared and solve, and I end up with the square root of 2. All right, so now what I would like you to do is find the sine of 45 degrees and do all 6 trig ratios for that. So the sine of 45 degrees, again, is just going to be like what we did before. It's going to be the opposite over hypotenuse. Now, let's say we're looking at this one. We're going to get 1 over the square root of 2. Well, what if we look at this one? We're going to get, if we're looking at this one, we get 1 over the square root of 2. If we're looking at this one, 1 over the square root of 2. So it doesn't really matter which 45, which means we only have to do this one time. We only have to find 6 trig ratios. So we ended up with 1 over the square root of 2, which we have to rationalize then, and we end up with the square root of 2 over 2. So go ahead and finish the rest of them, and we'll check our answers at the end. Okay, so this is the answers for all of these. And this right triangle, and I forgot to name the other one, but this one, when we have a 1 by the square root of 2 with two 45s, we call this special triangle. This is special, so make sure you spell special. My pen isn't working for some reason. I tried changing the battery, and it's still not working. All right. So this special triangle is called a 45 degree, a 90 degree. This special, which has side lengths of 1, and the square root of 2. If we go back to this one, this particular triangle is going to be called a 30, 60, 90 degree triangle. So those two triangles are special triangles. I just taught you 2 different ways to draw both of them. So start with an equilateral triangle because you get that 60, 60, 60, and then you can just build it from there. Or you're going to start with a square because you got that 90 degrees and you know you need a 45 and a 45. So all you're going to have to do is do that, and I will be asking you that stuff. So here is an example of what I might ask you. So on the test, I will say, give me the sine of 30 degrees. So if it's a 30 degrees that you're looking for, you know that you need to draw that 30, 60, 90 triangle. So we're going to draw 30, 60, 90. Thing to remember is the hypotenuse is always 2. I'm going to go ahead and make this 60 and make this 30. So then that means that this side length right here is always going to be 1. And because if I'm thinking about it, if I draw this out, there we go, there's the rest of that equilateral, and then I end up with the square root of 3. Another thing that I always remember is that the adjacent to 30 is always the square root of 3. 3 goes with 3, and then I can just put the 1 whatever's left. So if I want the sine of 30, that is the opposite side, which is 1, over the hypotenuse, so I'm just left with 1/2. This same one, this is the same triangle, but I need to find cosecant of 60. So I know that sine is opposite over hypotenuse, and I know that cosecant is the reciprocal, so this must be hypotenuse over opposite. So then I'm going to end up with the hypotenuse, which is 2, over the opposite side, which is going to be the square root of 3. So you end up with 2 times the square root of 3 over 3. And that is the final answer. And then the cotangent of 45 degrees, that means I've got to draw a different triangle. So I know my legs on a 45 are 1 and 1, which must mean that this is the square root of 2. And cotangent, so TOA is going to be the reciprocal. So we're going to have adjacent over opposite. The adjacent side of one of the 45s is 1. Is 1 over 1. And we end up with just 1. Here's a chart that could help you. I don't find it as particularly useful because I can just draw the triangles and I don't have to remember anything. But if you have trouble with that, I wanted to provide this for you. So those are all of the things that we've already found on the last few screens. Here they are for 45 and here they are for 60 degrees. So you can check your answers with those, but these all should be the same. Okay. All right, that's the video on all special triangles that we are going to be covering in this class. If you have any questions, please come to class with those questions. Otherwise, I'll see you another day.